This is a video on Jacobians. The question states, use a transformation to find the volume of the ellipsoid x squared over a squared plus y squared over b squared plus z squared over c squared is equal to 1. So the trick on this is to find the transformation that's going to simplify this ellipsoid. This ellipsoid looks a little like a sphere, except that we have an A, B, and C here. So the transformation that will take this ellipsoid and turn it into a sphere is we let x equals AU, y equals BV, and z equals CW. The reason why this works, for example, if we plug in x equals AU here, we get AU squared over A squared. And that's a squared u squared over a squared, which is just u squared. And similarly, I get a v squared and I get a w squared, which is u squared plus v squared plus w squared equals 1. And that's the sphere that I'm looking for in the UVW space. So I need to find the Jacobian. And the Jacobian is defined by del xyz over del UVW is equal to the determinant of the matrix of partial derivatives, x sub u, x sub v, x sub w, y sub u, y sub v, y sub w, z sub u, z sub v, and z sub w. So now we just calculate these partial derivatives, which turn out to be very simple. X sub u is just a. X sub v and w are 0 because there are no v and w's in AU. So I have A, 0, 0. And similarly, y sub u and y sub w are both 0, and y sub v is equal to b. So I have 0, b, 0. And for z sub u and z sub v, those are both 0. And z sub w is equal to c. So I get this matrix, which happens to be a diagonal matrix. And the determinant of a diagonal matrix is just the product of the diagonals, or in this case, A, B, C. So now recall the solid was defined as u squared plus v squared plus w squared was equal to 1. That's what happened after we performed the substitution in this ellipsoid equation. So now we're ready to put this together and use the change of variable formula that says that the volume, which is a triple integral over this solid, is equal to the triple integral over our new solid S times the Jacobian, which is, by the way, the absolute value of A times B times C. A, B, and C are assumed to be positive, so absolute values don't do anything to positive numbers. So we get A times B times C ds. I can pull out the ABC out of this triple integral, and the triple integral over S of 1 times ds, that's just the volume of this solid. But the solid is a sphere of radius 1 in the UVW space. And the volume of a sphere is 4/3 times pi times the radius cubed. The radius is 1, so 1 cubed is just 1, and it goes away. So the volume is ABC times 4/3 pi. So we can conclude that the volume of the ellipsoid is 4/3 pi times ABC. And I'm done with the problem.